Hello everyone, hello peeps, welcome back to another video on the mancubs channel. Today we're going to be doing some maths problems. These are the kinds of grade 8-9 questions you get at the end of the paper and will really help boost your grade before the exam next week. We've got less than a week until the exam. We're all going to be sitting it, and after the exam we're going to see what kind of grade 8-9 questions they come up with at the end of the paper, and this will help you push your grade just that little bit further. So let's get straight into it. With the first question, we're going to be doing section A today, probability and ratio. So there are some red and blue counters in a bag. The ratio of red to blue counters is 3 to 1. So the ratio of red to blue is 3 to 1. Two counters are removed at random, and the probability that both the counters taken in blue is 1/20. And what we're trying to work out is how many counters were in the bag before any counters were removed. So the first step in any problem like this is drawing a tree diagram. So we're going to do something like that. We've got red and blue. That's our first counter that we've taken, and then our second counter, because we take two counters, it's going to be like that. Might I add that it says two counters are removed at random. It doesn't say anything about the counter being put back, which means we're going to have to take one away from the total. So we know that the probability that both the counters taken are blue is 1 out of 20, so you can write that here, 1/20, like that. Okay? Since we know the ratio between red to blue counters, we can say that the probability of taking a blue counter is going to be 1/4, and the probability of taking a red counter is 3/4. But, yep, there's a big but. We're not going to do that, because what our primary goal in this question is to work out how many counters were in the bag, right? The denominator tells you, in a probability kind of question, the denominator, when it's not simplified, it tells you what the total number of that thing is. So we need to try and find what that is, right? So we can say that, although this is going to be 1/4, it's going to be equivalent to x over 4x. We are multiplying this fraction by some sort of quantity x that will be the fully unsimplified version of it. So we're going to be working with a bit of algebra here. So this is going to be x over 4x, like so. And we take another blue counter. So since we've already taken one, we've taken another. So it's going to be x minus 1. And the total overall is decreased by 1, so it's going to be 4x minus 1, like so. Now, you should know how probabilities work, that we're taking one blue and we're taking a second blue, so we can write an equation to represent this. So we've got x over 4x multiplied, because we're doing it and, right? X minus 1 over 4x minus 1 is equal to 1/20. So let's multiply this out, right? I'm going to use brackets for this first example here. So we've got x minus 1, like so, and then 4x minus 1, like so. And that is all equal to 1/20. Okay? Let's take it up here. So if we expand out this bracket, like so, this will just help you visualize it, we're going to end up with x squared minus x over 4x squared minus 4x. Or are we? That is the question. You can see I've made a mistake here, haven't I? I definitely did that on purpose. No, I did. It's meant to be 16x. This is a very common mistake. Make sure you properly expand brackets. Sometimes I think it's helpful to actually draw the lines in to show what you're multiplying by what, just so you don't forget any term. You don't like leave an x out or something, because that can have a knock-on effect on the problem. If you do that very early on, it can really impact the final answer you get. So now we're going to be doing a bit of cross multiplication. This is basically multiplying everything by 20, then multiplying everything by 16x squared minus 4x, and then cancelling out all the things that have been doubled up, basically. So we've got 20 lots of x squared minus x equals one lot, so we don't really need to do anything like that. 16x squared minus 4x. And then we're going to expand these brackets. So 20x squared minus 20x equals 16x squared minus 4x. You can see we've kind of got a little bit of a quadratic kind of thing going on. So that's what we're going to try and form. So if we subtract 16x from both sides, 16x squared, sorry, my bad. Then we're going to end up with 4x squared. And then we can do this in one go as well. Add 4x to both sides, like so. And then minus 20x plus 4x is 16x equals 0. And then we can divide everything by 4, just so we've got 1 as the coefficient of x squared. So we've got x squared minus 4x equals 0. I'll just set this up here. We can take out a factor of x. So we've got x bracket x minus 4 equals 0. As a quadratic, we've got two solutions, x equals 0. And then we've got x equals 4 using the zero product rule. And we've got our two solutions. But wait. We don't, do we? Because x is representing, well, in this case actually it's representing the number of blue counters, but it's kind of it's like representing a quantity of counters, isn't it? And we know we have more than 0 counters, so that means we cannot have x equals 0 as a solution, only x equals 4. But that isn't our final answer. I tell you why. Because x isn't representing the total, 4x is. So we've got to do 4 times 4, which is 16, and 16 is actually our total number of counters in this question. Right, okay, next question. Very, very similar problem here. So we've got some red and blue counters in a bag, like the previous question, and the ratio red to blue is 4 to 1. And two counters, like the previous question, are removed at random. The probability that both the counters taken are red is 22 over 35. And work out how many blue counters are in the bag, okay? So, what we're going to do for this question, very similar to the last question, draw the beautiful, beautiful tree diagram. Red, blue, like so. And we know that the probability that both counters taken are red is 22 over 35. So we can say that this, let me do it in red actually, this is going to be 22 out of 35. And let's look at the ratio now. So we know that the ratio of red to blue is 4 to 1, right? So we could do something like this over here, right? We could do a quarter and then, or in this case, a fifth and then 4/5, but we're going to do the thing with the x's again because we're trying to work out a quantity of counters, and I think that will help. So we're looking at red, so we don't need to worry about blue that much. So it's going to be 4x over 5x. That is equivalent to 4 over 5. So even though we are using the x's, it is the same. So the probability that we take one red is going to be 4x over 5x. Again, it doesn't say that we replace the counters, so we're going to assume that they're not being replaced. So the red is going to be reduced by 1, and the total is also reduced by 1. And we're going to do the same thing as before, form that equation. So 4x over 5x multiplied, because it's and, 4x minus 1 over 5x minus 1 equals 22 over 35. I'm going to try and speed through this a little bit more because we've done it already in a different question. So I'm not going to fuss around with this, we're just going to go really quickly through this. So it's going to end up with 16x squared minus 4x over 25x squared minus 5x equals 22 over 35. And then we're going to do a cheeky bit of cross multiplication there. And this is where this problem, I think I should have put a calculator on this paper rather than non-calculator. So we've multiplied that by that and that by that. 22 times 25x squared minus 5x. Now I think we need to get your calculators out for this one, because it's a bit of 2-digit multiplication here. So first of all, we're going to have to do 35 times 16, which is 560 x squared, 35 times minus 4, a little bit easier that one, minus 140, and then we got the x there, equals 22 times 25, that's going to be 550, x squared, and then 22 times minus 5, that's going to be minus 110x. So we've got quite a few big numbers here, and that's okay, because watch this, when we sort of form that quadratic like the other question, it is going to look a bit neater. So if we subtract 550x squared from both sides, then we're going to get 10x squared, and let's do this in one go like before. If we add 110x to both sides, then minus 140x, sorry, plus 110x is going to be minus 30x equals 0. Let's just take this up there. And then can divide everything by 10. Rewrite the whole thing. Divide everything by 10. We get x squared minus 3x equals 0. And then again using the zero product rule, taking out a factor of x equals 0 and x equals minus 3. But remember, because x in this case is representing a quantity, we can't use 0, because technically, right, if we look at this, x is representing like a fifth of the whole number of counters, so we can't have 0 like I've explained before. X equals minus 3 is our answer. Or is it? You can see I've made another mistake, haven't I? Just trying to trick you out. Remember, I've been rushing through these quadratics, haven't I? I'm just going to show you what we actually do. We equate each of them to 0, right? So then x minus 3 equals 0, because at least one of them has to be 0, so we can check for both possibilities. We add 3 to both sides and we get x equals 3. Don't make that mistake. And this one's actually a little bit easier, right? Because x is representing the number of blue counters. We only looked at the red counters at the beginning, but if we look at this, it would be 1/5, right? But then, because we're using the x's, that's going to be equivalent to x over 5x, where x is the number of blue. So that means we can just use this answer of x as our final answer for the number of blue counters. Right? Alright, the next question. A little bit different, this one, but still along the same lines. There are 4 red counters and X blue counters in a bag. 2 counters are removed from the bag at random, and the probability that both counters taken are blue is 1/3. So here we're trying to work out the value of X. They've been nice. They've already given us a value to work with, haven't they? Let's draw the tree diagram. Red, blue. There's a lot of red and blue in this paper, isn't there? We know the quantities, don't we? So we know that there are 4 red, X blue. Since we know there are only red and blue in the bag, we can work out what is our total going to be. It's just going to be red plus blue, which is 4 plus X, or X plus 4 as I'm going to write it. The probability that both counters taken are blue is 1/3. So we can write 1/3 here, like that. Now let's look at the probability for each step of this problem, shall we say. So when you're taking the blue counter first, right, it's going to be the number of blue counters over the total, so it's going to be x over x plus 4. But then, as the previous questions say, we don't replace it. It has nothing about replacing the counters, so we're going to be subtracting 1 from the total. So x minus 1 over x plus 3, because 4 minus 1 is 3, obviously. And then all we've got to do, like the other one, these questions do get very formulaic. We've just got to form an equation, multiply it, solve the quadratic, and there you go. So x over x plus 4 multiplied by x minus 1 over x plus 3 equals 1/3. Now this is going to be a little bit of a trickier one because we've got 2 terms in the denominator here on both of them. So we're going to be multiplying across. The top one is fine. I'm just going to do really quickly x squared minus x. If you still need to use your brackets, I would advise using your brackets, but I'm just trying to sort of go through everything, focus on the steps and the probability. We're just going to rush through this over, and I know I can do this in my head, right? But it's okay if you don't. I'm just going to really quickly expand this. So we got x squared plus 3x plus 4 is that's plus 7x. 4 times 3 is 12, so plus 12. But if you aren't confident with expanding double brackets in your head, I would heavily advise you do it by drawing the lines and stuff, because you don't want to make a mistake with that. And then here we're just going to do our cross multiplication. 3x squared, I'm just going to miss out on the brackets this time, just speed things up, equals, and then one lot of x squared plus 7x plus 12. There we go. Now let's start making this equal to 0, right? We can subtract x squared from both sides. We can subtract 7x from both sides. And then I'll get to the 12 in a moment, just so we don't clutter things up. So 3x squared minus x squared, that's 2x squared. Minus 3x minus 7x, that's minus 10x. Equals 12, and then we're going to 2x squared minus 10x. We're going to subtract 12 from both sides. Minus 12 equals 0, right? Now if you notice something about this quadratic, we don't need to use the splitting method or slide and divide or whatever. 2x squared minus 10x minus 12, so we get x squared minus 5x minus 6. And then this is going to be x minus 6, and then x plus 1 equals 0. Factorizing quadratic, it's quite an easy one, this one. If you don't know how to do that, please learn. There's loads of videos on YouTube, it's really good skill to factorize quadratics. And then here we've got two solutions, x equals 6 and x equals minus 1. I'm not going to bang on about looking at the negative. We've gone through about 3 times, so ignore this answer. Just going to look at this one here, right? X equals 6, and that's literally all they're asking us to do, find the value of x. So we can just say x equals 6 as our final answer. So this question is a bit of a tricky one. A and B are in the ratio 4 to 3, C and D are in the ratio 1 to 5. Given that this algebraic expression 3 lots of A plus B equals C plus D, find the ratio A to B to C to D. So it's a 4-way ratio. This is like the only question I've ever seen that's a 4-way ratio. But let's give it a go. It's not harder than it looks, it's easier than it looks, trust me. So when you've got something like this mixed in with a bit of algebra kind of stuff like that, what I like to do is convert the ratio into fraction. Everyone seems to forget you can do that. So since we know that let me change my colour for this question. Since we know that A to B equals 4 to 3, we can say that A over B as a fraction is equal to 4 over 3, like that. Then we can just do the classic cross multiplying. There's been a lot of cross multiplying in this video, hasn't there? Like that. And we've got a little nice equation, haven't we? I'm going to be looking at this thing now, okay? Let's take that. What I'm just going to do, I'm just going to expand those brackets. 3a plus 3b equals c plus d, right? And now, before we get into that, let's go look at this one here, right? Going to do the exact same thing. We know that c to d are in the ratio 1 to 5, like that. So we can say that c over d equals 1 over 5, can't we? And then just a bit of cross multiplying once again, and we end up with 5c equals d, right? So now let's look at this equation right here. Okay? Have you noticed that we've got a 3a here and a 3a there? We've got a d here and a d there. We can do a little bit of substitution, can't we? We can put this 3a equals 4b, so we've got a 4b there and a 5c there, so we only got 2 variables. And in reality, that's all we need, because we want to find the ratio a to b to c to d. We have a to b, we have c to d, all we need is B to C, so then we can find out like a common ground, which allows us to make the ratio true. Okay, so let's substitute that in. That one in there, and that one in there. So 4b equals 3a, we've got 3a here, so we're going to have 4b plus 3b equals c plus 5c equals d, so we have 5c there. Collect those like terms, 7b equals 6c, and then this is where we're going to put it back into a ratio for our final answer. Now you could do it straight from here, but I find that very confusing. For example, right, if we look at this one here, we know that 5b equals 3a, but that doesn't mean that b to a equals 4 to 3. It's the other way around, so you've got to be very careful here, okay? I'm going to divide everything by 7 here, so we get b by itself. b equals 6 over 7 times c over 1. I'm writing it like that because just to make it extra clear that we're going to be dividing by c on this side, and we're going to end up with b over c equals 6 over 7, right? We can now put this back into a ratio. So b to c as a ratio equals 6 to 7. So now let's look at the big boy, the four-way ratio. A to b to c to d. What is a to b? A to b given in the question, 4 to 3. Now let's look at b to c. We're going to treat this as a three-way ratio first. B to c is 6 to 7, but you can see that the b's do not line up. So we've got to multiply this a to b ratio by 2. So that means 6 is b on both individual ratios. So we've got 8 to 6 and then to 7 because we only need to multiply one side. Now let's look at c to d, 1 to 5, right at the end, alright? 1 to 5. We just got to multiply this by 7, don't we? So we get 7 to 35, and then all of this just stays the same. So 8 to 6 to 7 to 35. It is a bit of an odd ratio, I do have to say, but that is our final answer. 8 to 6, if it wants to let me write. 8 to 6 to 7 to 35. Oh my god, what's happening? There we go. That is a horrible. I tried to draw a square and it gave me a triangle. That is how bad I am at drawing with this. Honestly, there we go. That is a nice box. And the last question in this section, I'm not going to go through in this video because I've already got a video about it. Link in the top right hand corner in the description. As you can see, I've already highlighted this previously because in the original video I wrote that as E instead. You still get the same answer, but I just want to make you aware that the form in the question that I wrote in the video is wrong, but the answer and the working out and the method is all still right. So go check that out. Thanks for watching. I'll see you in part B of this video, part 2, whatever, and part 3 for some graphs and equations. We've got some great graph and equation question here, and we've got loads of hard geometry questions, which is amazing. So I want to thank you all so much for watching. If you enjoyed it, make sure to like. If you're new here and you enjoy these kind of videos, make sure to subscribe. All of this YouTubery stuff, share, comment, whatever that YouTubers like to say, helps out this video a ton. Thanks for watching, and we'll see you next time, or in a previous video, or whenever. Goodbye.